Welcome, guys. So, in our series of PostgreSQL, we are now starting our new topic, vacuum. Vacuum in PostgreSQL does a major role in update, delete, and reclaiming the space used by update, delete table plot. So, that's a crucial part of PostgreSQL to understand how vacuum works in a real time scenarios. Okay, so we are going to discuss that in our this lecture series of lectures. Okay, so now let's start our first tutorial for this. So, what is vacuum? So delete and update are not allowed to actually overwrite data as rollback would not work. Okay, so if we do the delete on a table, it doesn't like delete that row or delete that data. In case of rollback required, then you won't be able to do the get those rows back which are deleted by delete, which are removed by delete. So if you happen to be in the middle of a large delete operation, you cannot sure whether you will be able to commit or not. Okay, so if there's a thousand of rows you are going to delete, and in the middle postgre, or you are not able to sure that the delete will be gets completed in any case, server failures, network down, any case, if that happens, your data will be lost, and you're in a situation where you may or may not have the data. Maybe half of the data you have, that's inconsistent situation that will be. Okay, so for that, what vacuum does, okay, it's I'll tell you, okay, later. In addition to this, data is still visible when you perform delete. Okay, so if you are deleting and thousand of rows you are deleting, but the data is still there. You are still able to select the rows which you are deleting right now. Okay, and sometimes data is even visible once after modification are gone. Sometimes your delete is completed, and still you are seeing the data, because when you ran the select query, it was in the middle of when you are deleting it. Okay, when you are doing the delete. Okay, so consequently this means that cleanup has to happen asynchronously. Okay, like when you are not doing these transactions, cleanup should be done asynchronous, like apart from this that should be there. So a transaction cannot clean up its own mess, and commit rollback might be too early to take care of dead rows. Okay, so if we do the if we do delete or update, so and after some time we are before the any other transaction we are going to commit, so we cannot do. Okay, and commit will be like or rollback will be too early, to take care of the dead rows, like which are what are being dead after the delete and update. So the solution to this problem is vacuum. Like before doing the commit or rollback, we are just uh, uh, doing a script of series, and after that we'll be doing the commit. But we want the space after we our work, delete, update, insert, that just uh, increases the size of the table. So how to reclaim that size, how to use that size? The solution is the vacuum. So vacuum will visit all pages that potentially contain modifications and find all the dead space. Okay, so the free space found is then tracked by free space map of the relation. Every table has free space map, and table we call it them in Postgres relation. Okay, so every table, every relation has free space map, which is calculated by vacuum for every table. Okay, vacuum will in most cases not shrink the size of the table. Okay, instead it will track and find free space inside existing storage files. Okay, it will not shrink the table. Like after update delete, if the table size gets increased, we updated the table size is 10 MB and we make some insert update and now the table is 12 MB. So vacuum does not uh, so that after update and delete, we are not talking about insert will definitely increase the data of the table, size of the table, but in delete and update, just the we are updating or deleting the previous rows, okay, which are already there. But after these operations, vacuum will the table size gets increased, okay, because newer version of the rows will be there, and uh, space which is occupied once for the new by the newer versions, and older versions are or space are not reclaimed by the table, okay. So this is called this to reuse that space which is uh, the older versions of the rows, reuse that space, we can use vacuum. That's the major part of the space reclaim. uh, if you want to say reclaim or reuse the space, reuse the space right now, because reclaim is another thing. We can reclaim it with some other, but right now we are just talking about vacuum. So vacuum, if with vacuum we can just reuse the space, like uh, the we were discussing that size of table was 10 MB, and we are just we did some update and delete, and the table size gets increased and it is 12 MB now, okay. So vacuum, what does vacuum is, vacuum the extra 2 MB, it mark that space reusable, and that 2 MB will be in the free space map, so that other things will be using it, other data for the same table will use it, or uh, that table will be, if there are another option operations that will use the same data which is occupied by the table. So that if we are doing it manually, the syntax is vacuum and then the table name. That's quite simple, okay, if you want to do it manually. So how update work in PostgreSQL? Okay, so assume we delete some records from the database. Okay, that's Postgre does not remove those records from the database. These are just marked as deleted. So these are with the deleted records. Okay. Similarly, when a tuple is updated, is it is equal to delete and an insert. Okay, it is doubles the size, because first the older version is marked as delete, and there's a new version of the uh, row which is an insert of the same row with the updated values. The previous version of the record continues to be in the data file. Each of the updated uh, row generated a new version of the same tuple, okay. So this is how it works. uh, there's a there's one row we will be talking about right now. This is the one row with name Rohan and amount is 15,000. So when we update the salary or whatever the amount is, we update the amount to 18,000. The older version is still there, and we created a new version. So this is the insert, and this row is still there, the older row. But we'll be using the older newer version now. But this is still there at the disk, it is still there. Same like this, if we update to one or more two more times, the older version are still there. So we'll be accessing newer versions now, but still we there are older versions of the rows, and the data at disk will be the size of the disk that the table is using, it is 4 times now for a single row. So to overcome that, we have vacuum. When you update a row in PostgreSQL, what Postgre does is it copies previous rows and add new rows with updated values. See, it copies previous rows, and uh, updated values are with the new rows. Okay. Why it does so? Maybe your transaction requires rollback. Also, concurrent transaction may require the previous data. Okay, so maybe your transactions which are going concurrently at the same time, they may require the previous data, or maybe in case of once you are done with your whole transaction, you may be rolled back to this point. So that's why Postgres does not delete the rows. Okay, it just create new version of the data. So when you do vacuum, all of the new data will be inserted to the free space, which was made reusable. All, all older data, this is not the new data. All the older data will be inserted to the free space map, okay, which is made reusable with vacuum first and then occupy new data pages. Okay, so when you do vacuum, all this space, the older version of the records will be marked reusable. And if you make another update, delete, so once this space will be used first, okay, then it will occupy new space at the disk. Okay, so Postgres introduces version over row because of its active transactions which require data as it was before. Okay, so it supports newer version. It all the time it creates a new version until you do the vacuum and mark this space as reusable. Okay, so this is vacuum and how update works in PostgreSQL. In our next lecture, we'll be seeing how vacuum works in real time scenarios, or how vacuum works, how what are the full vacuum. Okay, so we'll seeing you in the next video. Thank you.